Welcome to section 4.1, where we're going to graph a set of linear equations. Now, linear equations is a fancy term for equations of lines. And we're going to graph two lines on the same graph, on the same plot. And because here we have one equation here and a separate equation there. And generally, when you graph two lines, unless they're in parallel, or they're the same line, they're going to cross. And where they cross, where they intersect, is going to be the solution to the system. So let's take a look at this. Now, it's actually not bad to graph on using this system here in my math lab. All you need are 2 points. That's all you need. Like, for instance, x plus y equals 10. Let's put that up here. X plus y equals 10. All we need to do is come up with 2 points that fit that line. And when you have the x and the y on the same side of the equation, you use what's called the intercepts, where pick a value of x. See, we're coming up with 2 points. Pick a value of x. Pick x as 0. It's going to cross the x-axis. Okay, when x is actually it's going to cross the y-axis when you have x as 0. What's the value? What's the corresponding value of y? If x is 0, what's the corresponding value of y that satisfies this equation? Well, if I plug in 0, 0 plus y equals 10, and y has to be 10. So if x is 0, I ask what's y, and then we say if y is 0. Okay, what does x have to be? Well, same deal. X plus 0 equals 10. This has got to be 10. So right off the bat, these are the 2 points I'm going to graph. So I'm going to click this, draw a line, pick that line, and see, they even tell you, they even help you when you're trying to plot what the point is, where the current point is. So I'm going to start in the center, the origin. 0, 10. 0, 10. Be careful. Oh, too far. There it is. There's 0, 2, 0, 10 right there. And then we want 10, 0. 10 is horizontal. 10 is horizontal. 0 is vertical. We don't want any vertical coordinate right there. There's that line for this guy. Now we do the same thing for x minus y equals 6. We need 2 points. When the x's and y's are in the same spot, what we use are the intercepts. If x is 0, what does y have to be? Well, if x is 0, this term is not even there. You're left with negative y equals 6. Negative y equals 6. I guess if I divide both sides by negative 1, y will be negative 6. And so we did the x is 0. If y is 0, okay, where we plug in 0 for y, and you pick zeros because they're easy to deal with. When you plug in 0 into an equation, the term goes away. So that's the reason why I'm picking zeros. Minus 0, x minus 0 equals 6. I guess x is 6. So those are the 2 points. So what I'm going to do here now is take those 2 points and graph them. Okay, and I'm going to say start in the center. 0 horizontal minus 6 vertical. Right there. Bing, click that. Now we're going to do 6, 0. 6 horizontal, 0 vertical. Stop right there. Okay, we've graphed the 2 points. You see this point where they cross? That point where they cross is 8, 2. See this where they cross? 8, 2. See, this is 0, 2, 4. Yep, 8, 2. And so check my answer to see if that's right. Good. I graphed them correctly. And type an ordered pair where they actually cross is right there. We just said 8, 2. Now, it's not enough to say 8, comma 2. That's going to be marked wrong. You need to put it in parentheses as an ordered pair. 8, comma 2. Check your answer. Well done. Now, I started in the middle because I have my own little technique to describe what's actually happening here. Now, when you're going to solve systems of equations, you're not going to use graphing. It's just these problems here work out nicely when the numbers are small, but when you have huge numbers, you're not going to graph like 150. Okay, so this is just to show you that the idea behind graphing, and when they intersect, it's a solution. And the reason why it's a solution is that it's that one point that satisfies both this line and that line. That's the only point that satisfies both, that makes both lines true. So in sections 4.2 and 4.3, we come up with better ways that doesn't require graphing. But let's go with this. What do we got here? Well, we still got a couple of lines here, so let's clear this out. I only need this scratch paper to generate my points. File, new, and I'm going to come over here and I say one line is y equals x plus 7. Okay, I need 2 points. Here's 1 point. I'm going to get myself ready. See, in this case, the x's and y's are on different sides of the equation, so it's probably best not to use if x is 0, what's y, y is 0, what's x. I'm going to pick a value for x. That's the x right here, 0. 0 plus 7, y's got to be 7. And then another good number to use is 1. If x is 1, 1 plus 7 must be y, which is 8. So those are 2 points that I'm going to use to graph that line. Now the x and y, the x plus 7, x plus y equals 7, has the x and the y on the same side. So in this case, I'm going to use, if x is 0, what does y have to be? And if y is 0, what does x have to be? So if x is 0, y equals 7. Y has to be 7. And if y is 0, this term goes away. X plus 0 equals 7. Those are your 2 points. The hard work is done. Okay, the hard work is done. The easy work now is, the fun stuff is to go in the graph, click it, draw the first line right over here with those top 2 points. 0 horizontal, 7 vertical. It's going to be right there. That's 0, 7. Click it. Then we've got 1, 8. Click that. Okay, now the next line. Next line, 0, 7. 0 horizontal, 7 vertical. Right there. 7 horizontal, 0 vertical. Boom, right there. We've graphed the 2 lines. Let's see if that works. Check your answer. Well done. And because they cross, see, there's 3 options here. And because they cross, you do have an answer. There is a solution, and infinitely many solutions. I have to show you what that looks like. But it's the fact that they do cross, you do have an answer. So I might as well use this little template here. And where do they cross? What's this point? X is 0, y is 7. So I'm going to put x is 0, y is 7. Check your answer. Nice. There you go. There's the answer for that problem there. Now, let's take a look at this one. These are fun. These aren't that bad. I think I'm going to use the same piece of paper here. Y equals 1/2 x plus 2. Well, since the x is on one side by itself, I'm going to pick x is 0. And 0 times 1/2 is 0, plus 2. Y has got to be 2. So we got 1 point. Now another point, you might say let x be equal to 1 like we did up here, but the problem with the number 1 is that 1 times 1/2 is 1/2, plus 2 is 2.5, which is 5/2, and there's no way to graph fractions on these graphs. You need to come up with a way to get whole numbers. And the way you get whole numbers is simply to pick a value of x that's equal to the denominator. Let's make x equal 2. 2 times a half is 1. Okay, because the 2's would cancel. Picture yourself plugging in 2 here. The 2's would cancel. Leaves you with 1. 1 plus 2 is 3. So there's 1 point right there. 1 line right there. Now we're going to do the bottom guy. And we say, well, if x is 0, plug in 0, y's got to be -7. I'm no mathematical genius, okay, because 0 is a wonderful number. 2 times 0 is 0, so this whole term goes away. You're left with y equals -7. And then the next thing is this, it's okay to plug in 1. 1. 2 times 1 is 2. 2 minus 7 is -5. There's your 2 points. Keep those points in line. Click on this graph. Make a line. And we're going to pick 0, 2. Horizontal 0, vertical 2. And another point would be 2, 3. 2, 3. 2 is horizontal, 3 is vertical, right? Oh, you could do 2. Oh, I saw there was a 2.5. Well, it's okay. Do what I said. Okay, that must be a new thing, a recent thing that they added to this, because generally you can't graph fractions. At any rate, that's done. How about the next 2 points? Draw another line. 0, -7. Start in the center of the world, the origin. 0 horizontal, -7 goes down vertically. And then the next point is 1, -5. Right there, -5. Stop right there. Did I graph them correctly? Yes, sir. And because they do cross, you have an answer. And that answer has to be in set of parentheses. And so what is that answer? That point has an x value of 6 and a y value of 5. So 6, 5. 6. And I'm going to put a 5 there. Check your answer. There you go. We did 3 graphs. Now I want a graph that doesn't come out. I want a graph that gives you some of these weird boundary conditions like this, like no solution or infinite many solutions. Let's see if the next one does it. And you know what? I think this next one does it. I think this next one is a strange bird. Or maybe not. No, it is. It's strange. It's strange. So let me take a look at this. So as far as you're concerned, they look like 2 equations. Okay, it's only that I've seen this stuff before that I noticed that there's something strange about it. But okay, first one, 5y equals 20x plus 5. All you care about is coming up with 2 points. That's all. All right, we'll pick x as 0. What does y have to be? If x is 0, 20 times 0 is 0. You're left with 5y equals 5, right? And if I divide by 5, y must be equal to 1. So that's 1 point right there. Now, what do we pick for the next point? Well, I don't see any problem with picking x as 1 and seeing what happens. Let's see what happens. If x is 1, okay, I'm plugging in 1. 5y equals 20 times 1 is 20, plus 5 is 25. And if I divide by 5, 25 divided by 5 is 5, so that's the corresponding 5. Yay. There it is. That's one line right there. Now over here, what do? Well, first we copy this. And what I'm going to do is say, if x is 0, what's y? And if y is 0, let's see, if I do x is 0, what's y? Y is 0, what's x? I'm going to get a fraction. Let's try something here. I just need 2 points. If x is 0, okay, I get 4y equals 4. And if I divide by 4, I get 1. So 0, 1. Okay. And you know what I'm going to do? Here the problem is, if I say y is 0, I get negative 16x equals 4, and I'm going to get x is equal to a negative 4/16, and you certainly can't draw that. I'm going to take a shot. I can pick a value of x, any value of x you want. If x is 1, okay, if I plug in x is 1, I get 4y. Now x is 1, so 16 times 1 is 16 equals 4. I'm going to add 16 to both sides. That becomes 20. If I divide by 4, I get 5. Okay. Interesting. This top equation generated these 2 points, and this bottom equation generated the same 2 points. So what does that look like? It looks like it's the same line. Let's see what happens when we, well, it's got to be the same line. Okay, I'm going to come over here. I'm going to click this, draw a line. First equation, 0 horizontal, 1 vertical. And then we've got another point, 0, 1, 1, 5. 5. That's the first top equation. Then they're asking us to do the bottom equation, and guess what? It's the same line that where these lines are on top of each other. 0, 1, and then we've got 0, 1, 5. Am I lying to you? Check your answer. No, I'm not lying to you. So, when you have the situation where you have the same line, they look different. These equations look different, but they are in actuality the same line. Okay? If they are the same line, then there's an infinite many solutions. Any number on one of these lines would satisfy the other line as well, because they're the same line. Okay? Now let's try this one here. Let's try this one here. Yep. I think this one's going to be, well, it's interesting to me anyway. Don't save it. And I'm going to say File, New. Okay. I'm going to do the first one. 2x plus y equals negative 1. And you know what? If I say if x is 0, what's y? And if I say if y is 0, what's x? X is going to be a half. I don't want fractions, but you can certainly do this. Why don't we do this? Just solve for y on this equation. I'm doing everything that's legal. Subtract 2x. In other words, get the x on that side. And so I got y equals negative 2x equal minus 1. See, it's negative 2x minus 1. They're not like terms. So I think this is better, because if I pick x as 0, y is negative 1. Why did I say that so fast? Because if x is 0, this whole term goes away. You're left with minus 1 equaling y. And it's okay for me to type in 1. If x is 1, remember the first coordinate is the x value. 1 times negative 2, you do your multiplications first. Negative 2 times 1 is negative 2. Minus 1 is negative 3. These are your 2 points that you're going to graph. Now the bottom guy is already a nice y equals equation. And I like that better, actually. The y, when you have a y equals equation, it seems like the points come out a lot better. If x is 0, I plug in 0, what do you think y is going to be? Yep, it's 2, you're right. And if I say x is 1, I plug in 1, negative 2 times 1 is negative 2 plus 2 is 0. Okay, let's graph those two things. So far they look like any other equation. Click the graph, click a straight line. 0, negative 1, click. 1, negative 3. There's negative 3. 1, negative 3. Click that. The other line, 0, 2. 0 horizontal, 2 vertical, and we've got 1, 0. X is 1, Y is 0. Something is wrong here. Something seems to be wrong here. Maybe not. Maybe not. No, see, I did something wrong. I did something wrong. Let me just stop. Hey, I think I graphed it wrong. I graphed this point wrong over here. Yes, I did. So what I'm going to do is clear this. Clear it. Start over again. Okay. Points are okay. Points are okay. 0, negative 1. 1, negative 3. I think that was off. Yeah, 1, negative 3. That's it. And then the next thing is 0, another line. 0, 2, 0, 2, bing. 1, 0, that's it. That's it. Now I knew that's the way it's supposed to look. Check your answer. Did I graph them right? Yes, after a little bit of work, I graphed them right. Now, they're not crossing anywhere. In fact, they're sort of in parallel. They're sort of in parallel. They don't cross. Okay, no matter how far you stretch up or down, they're never going to cross. And if they're never going to cross and they're in parallel, they're not the same line, there is no solution. There's absolutely no number that will satisfy both equations at the same time. So let's see if that's right. Great. Fantastic. So what I'm going to do is leave you with the other ones to do, other than this person here. Let's do this word problem. This word, and I think I could sneak this right over here. I don't think I need any special space. We assume that we've got Tom's Tree and Landscape Service charges $200 for just coming to your house, plus $50 per hour for labor. And that Lawn Perfect charges $325 with only a $25 per hour labor. Write a set of equations that represent the cost of the two. Okay, so the cost is is C, and H is the number of hours. Okay. Well, let's do the Tom's. I'm going to put it right there. Tom's Tree Service. Well, you're going to have to pay $200 for Tom just for coming to your house. Then when he starts work, he sets the timer. He's going to add to that $200 bill $50 for every hour that goes by. So if 1 hour goes by, it's another $50, $250. 2 hours, he charged $300. Same thing with Lawn Perfect. Now, Lawn Perfect is a $325 initial fee, but $25 for every hour. Let's check our answer. Nice. Okay. Now, choose the graph. Choose the correct graph. Which of these graphs sort of look like it models these things here? So let's make them bigger. Let's make it even bigger. Ooh, we can make them very, very big. Now, does this graph look like it should work? Let's see. One equation would be when h is horizontal. When h is 0, this looks like a line that starts off at about 500 and something. You know what? I'm not feeling A at all. I'm not feeling A at all. Okay, and this one is off the charts. This line here goes off to like Never Never Land here, like $700. See, the thing is, when h is 0, okay, these terms go away. I'm looking for the lines crossing the point 200 and 325 vertically. That's not right. That's not right. So let's try this guy. Let's try this guy and make it bigger. Nah, yeah, I'm feeling this one. I'm feeling this one. When h is 0, we have one line that goes at 200. It starts at 200 and increases. In fact, this has got a positive slope. Remember slopes? Y equals mx plus b. Well, this is your b. This is your 50 slope. It's got to be increasing, and this is increasing. As the hours increase, the cost increases. So this doesn't make any sense at all. As hours increase, you're paying less and less and less. So forget A. It's got to be B. But let's take a look. Let's see. So at H is 0, it's $200. When H is 0 for the other guy, it's $250, $300, $325. I'd say B is definitely the answer. Final check. Fantastic. So when do the services have the same cost? They have the same cost at this point. Doesn't matter if they work, looks like at 5 hours. 5 hours, it looks like this is $450. $450. So I would say they occur at 5 hours, for sure. 5 hours. Fantastic. I guess we're done. And it doesn't matter what equation you use. If I plug in 5, 50 times 5 is 250 times plus 200 is 450. And this would also, if I plug in H is 5, this would also calculate out to be 450. So that's a nice little word problem. So I only skipped the number 9. I want you to do one. I did the oddball cases. I did a few of these graphs. And again, these graphs aren't going to be the way you're going to graph in reality. In reality, you're going to use some sort of algebra to calculate these numbers. But let's take a look at this one. Determine whether this is, okay, determine whether this has got one solution or infinite many or no solutions. Well, I see only one line. They're telling me there's 2 lines. Well, those 2 lines must be on top of each other. And if they're on top of each other, they're the same line. So same line means infinite many. Okay, so let's go to number 2. Working backwards here. Determine whether this pair, determine whether 9, 6, x is 9, y is 6, satisfies these equations. And if this point satisfies both equations, then it's an intersection point and it's a solution. So what I'm going to do is take the first equation, 6, x, I'm going to plug in 9 for x. 9 is x, minus y is 6. Does that equal 48? 6 times 9 is 54. Minus 6 equals 48. Yeah, it does. The first line checks out. If it didn't check out, don't bother doing the second line. If this first equation didn't work, then it's not a solution. They both have to work. So let's go on the bottom here and say, well, plug in 3 times 9 is x minus 5 times y is 6. And let's see if that's negative 3. 3 times 9 is 27. You got to do your multiplications first. Minus 5 times 6 is minus 30. Equals negative 3. Now notice that 3 times 9 is 27, and when I do this multiplication, it's with the sign, negative 30. And it looks like negative 3 equals negative 3. That point, when plugged into both equations, is a solution. It works out. Nice. And then we're left with number 1, which I'm going to let you, it's impossible to get this wrong. Okay, you have 3 tries at this, and there's 2 possible answers. If the solution has no, I'll just answer it. If the system of linear equations has no solution, the lines are in parallel. They're in parallel. They don't intersect. Good job, and you can read that. All right, we'll see you in section 4.2, and we'll see you soon.